Now that we have the cylinder object selected, and let's evaluate it. It will return cylinder as expected. Now let's try this. Class of, then let's open a bracket to start a script group and go class of $, and close this command group. Let's evaluate it. It returns geometry class. Because at first Max will evaluate the script block that we have here, that returns cylinder as we saw before. Thus it simplified its code in its mind to this. And this returns geometry class, because the class of a cylinder is a geometry class. A simpler way to get this superclass of the given object is to use the function I mentioned before, superclass of $, which is basically the same as the class of $, line was. So if we evaluate this, it will return geometry class again. We can go further back in the inheritance chain to find the class of the geometry class. Whoops, there was a typo. I'm sorry. It's not class of. Now it is. It's node. So basically, the geometry class was derived from node, and cylinder was derived from geometry class. Now let's open up the MaxScript hub at the cylinder geometry class page. Type cylinder. There it is, geometry class. Instead of fiddling with the class of or superclass of functions, we can just check this page to tell what cylinder was derived from. Here it tells you that its superclass is geometry class and its superclass is node. Let's open up the help at node general properties. Node general properties here. Now this is where cylinder as an object started really. The 3ds Max developers first defined a class called node, which has very basic properties like name or material or what the parent object is of this given node. Wire color as a property is also here somewhere. There it is. So after having created the node class, they specialized this class even further to create new subclasses from it like camera, helper, light, geometry class, and so on. All these have their special properties and functionality. They are of course further specialized later, like we have free camera or target camera derived from the camera class, or the lots of different geometry types derived from geometry class. So when we want to determine the full list of properties of a given object, we have to also check the inherited properties, tracking back on the class chain. Anyhow, that might sound a bit advanced for now, so let's just get back to our tree creator script. Well, let's open the script. I closed it just before. My object creator. There you go. So let's go on explaining what each line does. So after setting the wire color properties, we set the basic position of the two objects here. Our objects inherited the position property from the node class, just as it was with the name and wire color. The cylinder, the trunk of the tree, is placed in the origin position, which is 0, 0, 0. Then we place the cone representing the branches of the tree to an elevated position, to perfectly sit on the trunk. This means that the z coordinate of the cone has to be the same as the height of the cylinder, which was 30 in our case, as you can see. Well, then we create the noise modifier, just as I explained before, and add it to the myCone object with the add modifier function. Let's evaluate the script just to make sure that this current version is the one that's installed into the system. I'll minimize the script, then run the script by pressing its button. Well, that's pretty cool. What is this good for? So far, not much, as our tree object is not easily moved around, being made of two separate objects, and it's created in the origin. We are still hanging in the air here. Well, if we wanted to create a nicely controllable tree placer script, we should at first create a plan on what we want to achieve and how the script should behave. Based on that, we can more easily develop our script. So, here's an idea. We could control the placement of the trees easily if the script placed the tree at each vertex of a given source object. Say we wanted a dense tree set, we could just tessellate the source object's mesh and run our script. So the workflow would look something like this. User creates a special tree source object with an appropriate distribution of vertices. Then use this script to place trees on the mesh. And then, if needed, use the deletion script to remove our forest, the old trees that we created. That would be user-friendly enough for our simple example, probably.